So today we're going to be talking about converting from degrees to radians, and the reason why is now that you're familiar more that a radian is a ratio of the arc length to a radius, and you also have graphed degrees and radians on a coordinate plane, it might be useful to be able to convert between them. So maybe some problems you can use either one as a gut instinct. Like if you understand radians better in this problem, use it. If you understand degrees better in this problem, use it. So converting is a very useful skill. Down here, I gave you two conversion rates, but here I want to ask you, where did that come from and why does it work? As I said in your notes packet, we want to be able to convert easily from degrees to radians and vice versa. I gave you this conversion rate, but rather than just saying, guys, I want you to use it because I know it works, I want to show you where it comes from. So let's think back to the last video. We said that in one revolution of a circle, so if we wanted to go all the way around in degrees, that was 360 degrees. And we also said that one revolution in radians, if we went all the way around this circle, ended up being 2 pi, or about 6.28 radians. And so by substitution, because both of these are equal to one revolution around the circle, we know that 2 pi is equal to 360, or 360 degrees. So if I divided both sides by 2, I'd get that pi, or halfway around the circle, is equal to 180 degrees. So this is where these conversion factors come from. So if you want to convert from one to the other, it really has to do with units, and let me show you why. My first question is, so how big is 1 radian in degrees? Now, some of you might remember from the last video, I showed this picture. So you had a circle, and then you had like a little portion of the circle, which we called a radian. And we didn't know exactly what the degree measure of that radian was. We just said that all the way around was about 6.28 radians, but we don't know the actual degree measure of this angle. So if we want to use conversion, we know that we have 1 radian. And if we want to convert that, now I'm going to put radian in parentheses because remember, technically, if I gave you an angle of 1, it would just look like 1. You would not have the word radian there, but I'm just doing it to prove a point. If we want to either convert by 180 over pi from the first slide, or pi over 180, we need to decide which one's going to help my units cross out. So let me write a fraction over here. In order to get the radian to cross out, we need radians on the bottom, because again, we want no units. So we have to decide. If we look here, we have degrees on top, pi on bottom. Here we have degrees on bottom, pi on top. I'm thinking we're going to choose this one because we want to be able to cross out radians with radians, and the pi does not have a unit, so we consider it's in radians. So if we crossed out those units, we'd end up getting 1 times 180 all over pi, which is the same thing as 180 over pi. And if we found that as a decimal, 180 over pi is 57.296, which means that my angle here would be 57.296 degrees. So 1 radian is equal to 57.296 degrees. That is another useful conversion factor. Speaking of conversion factors, let's get more practice. First, let's practice going from degrees to radians. And everything again has to do with units. For instance, if we look at this first example of 45 degrees, we want the degrees on the bottom so that the degrees cross out and we're just left with radians because we want to convert to radians. So again, we have to decide if it's going to be 180 over pi or pi over 180. Well, which one of these, so these should have degrees on them, which one of these options has degrees on the bottom? This guy does. So we'd have 180 on the bottom, pi or pi radians on the top. The degree symbols would cross out, which is a good sign. And also, some of you might be noticing that you can reduce 45 over 180. I kind of cross cancel. I know that 5 goes into both 45 and 180, but I also know that 45 goes evenly into 180. How many times? Well, exactly 4 times. So that means that I can cross out the 45 and make it a 1, because 45 goes into 45 once, and 45 goes into 180 4 times. So we have 1 pi over 4 left over, or just pi over 4. So the exact value in radians is pi over 4. And in my calculator, if I took pi divided by 4, I would get about 0.785 radians. The process does not change if the angle is negative. So if I have negative 70 degrees, I would then say, okay, just like the previous problem, I want everything in terms of radians. So I'm going to put 180 degrees on the bottom and pi radians on top, so that my degree symbols would cross out. And then I'd say, can I reduce negative 70 over 180? I know that 10 goes into both of them, or if you had negative 70 over 180, the zeros would cross out in a way. So you'd have negative 7 pi over 18. So that would be your exact value. And then if you took 7 pi or negative 7 pi over 18 in the calculator and divided that, that is about negative 1.222 radians. So what I'd like you to do is pause the video, and I would like you to try to convert 180 degrees and 300 degrees into radians. And I'll be back with you with my answers in a bit. So please pause your video now. All right, guys, here are my final answers for 180 and 300 degrees. I had the exact value would be pi, which kind of makes sense with your conversion, which was about 3.142 radians. And the 300 degrees, I ended up taking a 60 out of both 300 and 180. So I ended up getting 5/3 pi, or 5 pi over 3. If I took 5 times pi and then divided that by 3, I got that to be about 5.236 radians. So these were my final answers for those two. Last example for this video, or examples, we want to be able to convert the following from radians to degrees, because sometimes that might be more useful in an upcoming problem. So if I start with 3 pi over 2, and I think about conversion, we want to be able to convert this into degrees. So right now, the 3 pi over 2 really has radians. So if I multiply again by the fraction, we have to decide if we're using this or using this. On the last slide, we ended up using this one because we had the degrees on the bottom. We don't want degrees on the bottom this time. We want radians on the bottom, so it crosses out and we're left with degrees. So I'm going to put pi on the bottom. I'm going to put 180 degrees on the top. Technically, in parentheses, I will write radians because the pi is in radians and the 3 pi over 2 is. Remember, on a test or quiz, you do not need to write radians like this because you technically don't have a unit. I'm just doing that for the video to help you understand that they cross out. Not only does the idea of the radian cross out, some of you might notice that the pi's also cross out. So you would really have, let's see, you would have 3 times 180 all over 2 if I crossed out the pi's. Then 2 goes into 180 90 times, so you'd be left 90 times 3, or 270. 270 what? Degrees. Do you have a rounded answer here? No. So the answer would just be 270 again. So this one was nice because your pi's crossed out. And what I want you to know is that if you see a pi, I would not assume it's in radians. Sometimes you could have a degree measure in radians with a pi, so please don't assume that because you see a pi that it's in radians. Let's take a look at the next example. If I want to convert 60 into degrees, again, this has no unit, so I would assume it's in radians. So if we start with 60, technically we don't have this again, but we have 60 radians, so we want radians to cross out on the bottom. Pi is in radians, 180 would go on the top. So we would have the radians cross out, but unfortunately we don't have a pi up here this time to cross out. So we have 60 times 180, which is quite a large number, 108,000, and then we have pi on the bottom. This, oddly enough, is our answer that's exact. 108,000 all over pi. If I actually took that number here and divided that by pi, I would get about 3437.747 degrees. That is a lovely angle. 3,437.474 degrees. On that lovely note, what I would like you to do is take a look at these next two examples. See if you convert them into degrees. I will be back with you to show you my work and see if you got the answers right. So please pause the video now. All right, guys, so to check back in with you, if you take a look at this example, what I did was I took negative 16 pi over 3, multiplied that by 180 over pi, got the radians that are not really there to cross out, got the pi's to cross out, ended up with negative 16 times 180 over 3. I noticed that 3 goes into 180 60 times, so I was left with negative 16 times 60, which is negative 960 degrees, which is the same as the rounded answer. This lovely example, though, I started with negative 3.5, put radians in parentheses. I multiplied again by pi over 180 over pi so that the radians would cross out. Then I was left with negative 3.5 times 180 over pi. So one thing I didn't do last time that I corrected is that I wrote negative 630, which I got when I multiplied this, over pi all in parentheses with a little degree symbol, because all of this is in degrees technically. So back here, notice that I put parentheses around the answer with a little degree symbol because this is really in degrees, so I would make sure to change that. If I took negative 630 divided by pi, I got negative 200.535 degrees. Okay. So tomorrow, if you have any questions about it, feel free to ask me or feel free to ask your teacher. Remember, it's all about units, all about crossing out units. All right, see you next time.